Okay, good afternoon, and in a small number of cases, good morning, everyone. I've still got people arriving, but we'll actually hand over to Nick and Robert in a moment. First of all, thanks to both of them for agreeing to talk to us about thin provisioning for zOS disk devices. Big departure. It's been around for a few years, but I'm sure that there are lots of things still to understand and experiences still to be gained from it. A little bit about session logistics. Please open your Zoom chat window, and if you want to ask any questions, then please put them in there. It may be possible to answer some of them as the speakers are going through, but if not, we'll have a wrap-up session at the end. And when we've finished that wrap-up session, then I'll allow people to unmute and actually do this old-fashioned voice question thing. And with that, I'd like to hand over to Nick Clayton to start us off. Nick, the floor is yours.
Okay, so welcome to this session of the virtual GSE conference, and in the next hour, Robert and myself will be talking about thin provisioning on zOS. I'll start off by talking about more the hardware, the storage system aspects of the technology, and then I will hand over to Robert, who will talk about the DFSMS, the storage side of the picture, which together give us the capabilities that we have on zOS. So you look at the agenda, we've got a range of different things we'll cover, starting at the basics. Hopefully people are familiar with the general concept of thin provisioning. Talk about the base functionality that we have on the IBM DS8000 storage system, and then talk about a range of different aspects in terms of how it works with replication, how people typically convert to thin provisioning, and then getting on to the software side that Robert will cover. So just in case there are people who haven't really been following this area, it's useful to start just with a quick overview of what do we mean by when we say thin provisioning. And really the base of this is that you are allocating physical storage, physical capacity on demand. Only when data is written to the volume, to the part of the volume, do you actually allocate physical capacity. So without writing to a volume, you could have a 1 terabyte EAV volume, and if it's never been written to, it won't consume any physical capacity. The host would see the whole capacity as if it was fully provisioned, and actually if you read from the volume, you will get uninitialized tracks synthesized by the storage system, because we have to provide that view as if it really existed, but only when you write to it will you allocate capacity. Now, it's not necessary to do over provisioning with thin provisioning, but typically that's one of the reasons you would actually do thin provisioning, is to have more provision capacity than you actually have physical capacity. But I think the important thing to recognize, and something we'll talk about, is it's not mandatory. And in fact, you may very well start a thin provisioning journey by not over provisioning at all, because if you don't over provision, you can't run out of space. On the other hand, if you do over provision, that's one of the risks of thin provisioning, is if you don't have the space and you try and write data, there is no magic. We have to handle that and prevent those writes from occurring. So got the allocation on demand, and then over provisioning as the kind of exploitation concept. IBM's been trying to come up with a consistent set of terms across, all the various storage products for this, and 3 terms we kind of end up using here in the presentation. The first thing is the usable capacity of a system, the amount of capacity that's available for storing data. So I've got a 400 terabyte storage system. The usable capacity is that 400 terabytes, the amount of fully provisioned volumes I could create. The provision capacity, which we talk about, is then the sum of the host volume capacity, the sum of the virtual capacity of the environment, and that can be much larger. And if it's larger, we talk about this over provisioning ratio, which is the ratio of one to the other. So if you had provisioned equal to usable, you would have an over provisioning ratio of 1, and you could guarantee to be able to write all your data to every volume. If you had an over provisioning ratio of 2, you've got twice as much host capacity, provision capacity, as you have usable. And that's something that typically, if you are over provisioning, people might have some policies which said, I will not go beyond a certain ratio because I believe that would be, risking trying to squeeze too many pints into the pot. So if we go back a bit, there's, as the thin provisioning technology first started to appear, and especially on the enterprise storage systems, there was this kind of received wisdom over the years that said, we're very efficient on zOS in terms of storage. It's already 80% plus. Therefore, we don't need to, to do thin provisioning compared to the distributed guys who are very inefficient. And I think what's interesting is that was definitely true in the 1980s and 90s. Nowadays, when we look at different environments, it obviously varies, but not all zOS storage systems are running at efficient capacity levels, even if the storage team might be saying, well, we need some more storage because this team or that team needs some more. You could be in a situation where the actual usage of the system is only at 40–50%. It's just you've got stranded capacity. You might have 3 or 4 sysplexes on the same storage system, and within each sysplex, you've got storage groups, and maybe this team has a storage group that's underutilized, and the DFSMS setup can have a massive impact on the efficiency, and not all DFSMS setups are optimized for optimal utilization. So there can be stranded capacity either within a sysplex at a storage group level or between sysplexes, because each sysplex has spare capacity to use, resulting in there being a lot more available capacity than actually is being consumed. The other thing about thin provisioning is there are benefits beyond just, not using capacity that hasn't been written. And I'll go through these, but in terms of RAID rebuild now, on the latest version of the DS8000 microcode, RAID rebuilds are faster in a thin provision environment. Replication can be more efficient, the tiering functionality, or all sorts of benefits to do with the fact that unallocated space now doesn't exist. So we don't have to do anything with unallocated space. We only have to manage the allocated space. So I'll talk now about the DS8000 technology and how we enable thin provisioning. Obviously other vendor storage systems have slightly different technology, but the base concepts in terms of dividing things up and doing allocations and virtualizing of volumes is very similar, no matter the technology, whether it's DS8000, other IBM storage, etc. At a high level, the concepts are similar. And on the DS8000, we always had this volume virtualization technology, where even back in 2004, when we introduced the DS8000, a volume is simply a set of chunks or extents. And that was a decision taken at that time to enable future function. And this is one of the future functions that virtualization technology was aiming to support. So a volume is simply an ordered list of extents or chunks. And back several years ago, when we introduced the full thin provisioning support, we introduced a new small extent size, which enables a much more efficient thin provisioning. So we used to have 1,113 cylinder extents for CKD and a gigabyte for fixed block. Now we have a 21 cylinder extent, 17.5 megabytes for CKD, and around 16 megabytes for fixed block data. So now a volume is simply a collection. If you use these small extents, and we would recommend virtually everyone uses small extents, of these small 21 cylinder extents. The other thing, if you look at the storage system, you'll see in the reports that it's not just the volume data, your data, that we have extents for. There's also what we call volume metadata, which is carved out of the same pool of extents. And that has track format data, copy services, bitmaps, etc. It's typically about 0.5% or less of the capacity, but that comes out of the same pool. So, there's both data and metadata in the storage pool. And, the interesting, and I guess, hopefully a well-known number now, the 21 cylinder size that we have is the same as the cylinder managed area on EAVs, which was why we chose such a kind of peculiar number to match the allocation unit on the host for EAVs. So, as I said, there's a recommendation now that pretty much any DS8000 configuration should use small extents. The exception would be really if your configuration is too large to use the small extents. And we have two kind of sizes of configuration that we support. One, if you've got half a terabyte or less of system memory on the system, and the other one if you've got a terabyte or more. So with the small systems, we support around half a petabyte, roughly speaking, 560 terabytes of real capacity. And with the large cache up to 2.2 petabytes, which, there are systems out there bigger than that, but they are reasonably few and far between. And it can often be a decision point as to the system the memory you would have based on the capacity of the system. The other aspect to this is if we're doing thin provisioning and over provisioning, what's the maximum provisioned capacity, the actual virtual capacity of the system? And that's basically around twice the maximum real capacity. So, 4.4, 1.1 petabytes of capacity. So if you're doing over provisioning, whether with flash copy or nowadays with technology like safeguarded copy, you have to add up the virtual capacity of all the volumes and safeguarded backups and flash copies to get to that maximum limit. So, it's not that there's an infinite amount of usable space. The tables, the metadata structures are limited, as you can see there. But let me kind of reinforce something, because we have had a number of situations where people have had to reconfigure systems because they either deliberately or accidentally configured them with large extents. It's, you know, really, you have to, unless you've got a very good reason, the small extents should be considered the default for configuring the system. And to reconfigure is a bit of a challenge because you have to, the arrays are formatted when you create them. So you either have to empty the data completely off the machine or partially off the machine and kind of use some swing space to reformat things, which is quite messy. So configuring things up front with small extents is definitely sensible. So not much really more to say on this than I've already talked about. The other term we use for thin provision is extent space efficient. And as I said, you know, thin provision volumes are created with no allocated extents for the volume. The metadata is allocated at volume creation. So if you create thin provision volumes, you'll see the metadata, we call it overhead capacity, being used, and you know, you'll get that 0.5% or whatever of capacity allocated, and then as you use the volumes, they would be see the extents allocated. There's no additional licensing. It's all in the base function for this, which wasn't the case on earlier models, but on 80 and 8900, it's in the base function. And you know, there's no requirement to segregate if you want some fully provisioned, some thin provisioned. They just all come out of the same pool. So one of the things you obviously want to be thinking of when you're doing thin provisioning is capacity management. You know, in traditional terms, capacity management is you configure your volumes on your box, and all your capacity management is within DFSMS, etc., within the system. When you start doing thin provisioning, you now need to consider that the system view of the world is not really the true view of the capacity usage. And so we have various kind of thresholds and limits that can be configured to help manage that. The first one is this over provisioning ratio limit. So if you want to prevent anyone accidentally doing over provisioning in a thin provision environment, you set that to 1, and you guarantee that if someone tries to create a volume that would be greater than the physical capacity available, then the volume creation will fail, just as if it was fully provisioned. Or you could say, I want 50%, 100% over provisioning, and it just means if someone accidentally tries to create 100 1 terabyte EAVs, and that would go above the limit, they'll be prevented. The next item is an alerting threshold. So that says if the available extents falls below this value, then there'll be an alert. And I'll talk about the different alerts that will come out. It's not just SNMP, there's a whole range of different mechanisms for alerting that. And something occasionally some people do is to actually say, even though I've got 100 terabytes in my pool, I'll actually set a limit to 90. So that says if I start to get into trouble, I can have a reserve that I bring into use without installing extra capacity. But obviously, if you don't set that limit, you can use all the capacity anyway. So long as you've got the right reporting and alerting, this is maybe of questionable extra benefit. In terms of monitoring, on the storage system level, Robert will talk a little bit about what's available up on zOS. We have in the GUI interface both current views of the capacity, and you can see that down on the bottom left on the front dashboard. You can see the used capacity broken down into the various different usage and then the available capacity. And we also have a historical reporting capability. It's been enhanced in the latest release, which will let you go back up to a year, and you can see on a literally a minute by minute basis the usage of the system. Now, obviously, if you're using fully provisioned volumes, this won't be particularly interesting unless you actually create new volumes. But if you're using thin provisioning, especially if you're using things like flash copy or safeguarded copy, this can vary over the hours of the day. And so you could actually see what your peak values and what the lowest values are. So, various capabilities in terms of looking at the usage of the system. From an alerting perspective, as I mentioned, we got this threshold value, and there's also a I am full alert as well, which you hope never to see. So we define that threshold or leave it at the default of 20%. If you go above that value, a alert is generated. If you fall below the value, you get a under threshold alert as well. It is available via the SNMP traps on the DS8000. To be honest, nowadays, I would say the rsyslog functionality that we have on the 8880 and the 8900 would be the mechanism to use if you want to use something other than the zOS messages that that Robert will talk about. And that's a standard rsyslog function. And what's interesting, if you actually wanted to get that onto zOS, there is a syslog daemon on Unix system services, so you could actually stream it into zOS from the rsyslog function, or you can send it to Splunk or various other distributed automation and event management platforms as well. And the rsyslog function has a lot more. All the events that you get on the system will be sent there. So call homes, even audit messages about creation of volumes, deletion of volumes. So there's a lot of rich information there. The other thing which is new in our release 9.1 on the 8900 only is a optimization on the flash drives for thin provisioning. So the flash drives we've got now have a set of query capabilities and that enable us to exploit the unmap functionality on the back-end drives. So now we can, if we delete a volume, free up some space, not only will we return the extents to the pool and enable you to use that capacity for something else, but we will go to the back-end drives and we will tell the drives free that space. So that now becomes part of the flash free space pool on the drives. And then, when an extent is allocated, they can then be written again. But actually, what's interesting is flash drives perform better when they've got more free space. And so, using this function means that we maintain a larger free space pool in a thin provision environment, and the drives will act more efficiently. So their wear and their peak write capability will actually be significant, or will be better than if they were fully 100% allocated. The other thing is, if we do a RAID rebuild, the RAID rebuild function also knows where the unallocated space is or can query it. And so if I had a 50% allocated RAID array, it'll only take around half the time as if it was fully allocated. So the rebuild times there will also be significantly better if you're not 100% allocated. So, other benefits, even if you're not over provisioning or doing, to take advantage of having more space. So Part of thin provisioning is not just allocating space, but being able to release space. And we support space release function for both fixed block and CKD environments. From a DS8000 perspective, we have a special DSO, data services only command, which specifies a range, not a rang, of the volume which should be released. So the host software, which Robert will talk about, is able to tell the DS8000, I'm not using this this range of space, so you can feel free to release it. Then we can release the extents that are covered by the command, and a background process can then prepare the extents for reuse. Used to be that was a formatting process. With release 9.1, that's actually an unmap command on the backend drives. So there's two parts to it. There's receiving the command, and then there's asynchronously preparing the backend. And we also have now an ability with all the various different copy services functions to execute the space release, not just on the device that received it, but on other copies of the device. So if you have MetroMirror, we will execute the space release on the primary and the secondary. If you have Global Mirror, then we will execute it on the primary, and after some delay, because the Global Mirror might not actually be current at the point you issue the command, you have to have some delay, we'll issue it on the secondary. If the mirroring is suspended, we can obviously only execute it on the primary, and there's some conditions we still have to reject the commands. If you're just about to transition from pending to, or transitioning from suspended to duplex with MetroMirror, then we reject it until you get back in duplex. If it's a flash copy source device, today we reject it, or an XRC source device. The thing we've added recently with release 9.1 is if you're doing safeguarded copy and you do a space release, we will wait until the data is no longer required by the safeguarded backups, and then we release the space. So it's a delayed space release. And this is something we've been improving over time. We just added the safeguarded copy support, and there'll be a couple more enhancements in the future to complete the lists there. The other thing from a copy services perspective, you see here, if we're suspended with MetroMirror, we don't do the release on the secondary while we're suspended. So whenever I establish a pair or resynchronize a pair, then a space release will be performed on the target to match the allocation on the source and target. And this is an interesting thing, because certainly I was talking to one of our clients over in Scandinavia recently. They're fully thin provisioned, and they're a GDPS environment with GDPS PPRC or GDPS Metro. Now, in the past, when they were fully provisioned, they had this whole process to add devices into the PPRC environment. What they said with thin provisioning is, I just add them to GeoPalm, do the GeoPalm, run a start secondary, and that literally takes about 40 seconds, because we're not copying any data. We're just making sure source and target are identical, and if the volume is empty, they're both empty, and they then go into duplex. So the process, that someone more involved process they used to have around copying devices outside of GDPS and then adding them in is something they don't do anymore, because it's just so quick. And there's the time at which hyperswap is disabled is basically loading the config plus 40 seconds. So operational simplification for the adding new volumes to the environment. Flash copy, also when I establish and withdraw flash copies, we'll perform a space release. Robert will talk about some of the kind of complexities around that with DSS, etc. The only thing to remember is if you're using preserved mirror, the withdraw with preserved mirror doesn't release space on the secondary target. So in those cases, actually using an explicit space release would help actually perform the space release. And XRC is not prohibited for thin provision volumes, but it isn't thin provisioning aware, so it doesn't really help because the initial copy process will fully provision the devices. And as we announced earlier this year, we've kind of announced the stabilization and eventual retirement of XRC. So we don't intend to make any enhancements for XRC for thin provisioning. And certainly moving to global mirror would be the direction we'd be encouraging people to take. And speaking of global mirror, one of the early exploitations for zOS users for thin provisioning was flash copy and the global mirror journals. And typically you can have maybe 10 to 30% of the capacity rather than 100% for the global mirror journals. And in normal running, we typically see 5% or less allocation. Basically, the reason you'd have 10 to 30% is to maintain that golden copy if you were suspended for a few hours or 24 hours or whatever, if there was some major network outage, to retain the golden copy on the resync. So the usage is typically even lower. And just a little technical detail there, global mirror is using flash copy, but it doesn't perform a space release every time it does the flash copy. There's some special function in there to do it occasionally based on an algorithm that looks at the time since the last release, how much capacity is allocated, etc., to just occasionally free up some space. So, really one of the first use cases that people had. Now, this is something really just to kind of put it all together from a storage perspective. So, if you were to have a fully thin provision environment on zOS, you might have an MGM environment. So a local metro mirror, primary, secondary, and then a global mirror with your global mirror journals and a DR testing copy. Now, if you thin provision everything, the primary and secondary are, maybe you set the over provisioning limit to 1, so you can't run out of space, but you only allocate the space you need. So here we're a little bit under 50% utilized. And the global mirror target volume will also be utilized that much. The global mirror journal will be a subset of that. And the DR testing flash copy, unless you're doing a DR test, will take no space. So, even if you don't over provision on the primary and secondary, now my DR site is seriously underusing the capacity because even the source is not fully provisioned. So we've seen people go down, if you fully provisioned everything, there's 3x the capacity here. With thin provisioning, I've seen people go down to 2x or even 1.5 times the capacity if they're willing to push things that far. So for a development environment where you're doing global mirror, you might not do a large amount of DR testing, and you can really push the capacity down by exploiting thin provisioning everywhere. In terms of migration, just say a couple of things before I hand over to Robert. TDMF for some time now has had, or for a long time, has had the fast copy option where it only copies the allocated cylinders. And actually, I've just realized I have an old version of this chart. It used to be that fast copy was not the default, and so you would have to specify it with one of the, let's say, more recent versions of TDMF out a couple of years ago. The TDMF will detect that it's doing a thick to thin migration and will set the fast copy option so that it only copies the allocated cylinder. So you can do a thick to thin migration there and only copy the space that you actually allocated. And you can obviously do a space release, afterwards, making sure that everything is correct. The other way that people are using to migrate to thin provisioning, especially on a new storage system, is to do it with PPRC. PPRC is a lot faster mechanism often than using TDMF for migration. And for quite some time now, on the 8080 and 8900, we now have the support to do mirroring from thick to thin volumes. And obviously, when you do that, the initial copy fully provisions the volume, but as soon as you cut over to use that volume, you can then do some free space commands, and you will free up the space that's been used. So you do need the space to fully migrate the environment in, but you can then release the space following the migration. So, as usual, I've overrun slightly, but hopefully Robert won't be too distressed by that, and I will hand over to him to talk about the DFSMS support.
Not at all, Nick, and thank you. So when we talk about thin provisioning from a zOS perspective, there's really just a few aspects that we want to talk about today. Really, we want to talk about alerting and monitoring, and also managing that space within the extent pool. And you can go to the next slide. So really the question becomes, why not use thin provisioning? Their performance is comparable. So what are the trade-offs, right? Now, if you're not going to over provision, there really are no trade-offs. There's efficiencies gained through the mirroring. That's Nick's talked about it, everything like that. So we'll go through and talk about how we manage those volumes on zOS. And we'll spend quite a bit of time on the little edge cases where we need to clean up space that didn't get cleaned up otherwise. So let's go on. So thin provisioning has been around for a while. The majority of the support on zOS is in the base 2.3 release and 2.4 release. There has been an enhancement to the space release command that we're going to talk about, and it's available with PTFs on 2.3, and it's in the base as well. So mostly everything we're going to talk about today is in the base operating system. Go ahead. So the first thing we want to talk about is the alerting that we provide on zOS. And so by default, when you configure your system, you can give it a threshold, a capacity threshold, and we will issue an alert when that threshold is met. We'll also issue another alert, no matter what you've set the threshold at, we'll issue it at 15% capacity remaining. And finally, extent pool exhausted. Now, one thing to point out here is you see these alerts for volumes that are online to the host. So if you have, your global mirror secondaries that aren't, grouped to the system, you're not going to see any extent pool alerts for those. So really, I think this is good for certain use cases, for hyperswap use cases and things like that. But there's other alerting mechanisms that can allow you to get the full view of the capacity used throughout your environment. Next slide. We've updated our IDCAMS list data output to show you not only the capacity, the provisioned capacity, but also the used capacity. And so if you see here, we have a standard volume with the, the usable and provisioned is the same. We have an ESC that used large extents. And then down below on the bottom here, we have two thin provisioned volumes using small extents. And so this reporting really could be helpful in augmenting your batch jobs that'll use the space release command. So you could do this itcams list data prior to the space release and then after the space release to get some information about how much space was released back to the extent pool. RMF reporting. So we've always reported on extent pool statistics. We also tell you about the provision versus usable capacity. And this is nice to, if you turn on thin provisioning and you go fully provisioned, you don't over provision to start. You can use the RMF data to gather statistics about your system, right? So that the next step in the journey to over provision, you'll have some data to say, hey, I can go 30% over, safely. So the rest of the talk, we really want to spend talking about releasing space. So when is space released? So first of all, allocation of extents happen when writes occur. But when do those extents get returned back to the extent pool for use by some other volume, other logical volume, right? So space is released when we initialize a volume using ICK, DSF, and init. It's released on a flash copy withdrawal. When a data set is deleted, as well as internally during flash copy established. So if you say, okay, great. Internally, if I go and delete a data set or init a volume, space is released. Well, why do I need to worry anymore about that? And so we'll talk some more. Go ahead. So as data sets are created and deleted, space may not be released back to the extent pool. And so in order for the DS8000 to return one of those chunks or one of those logical extents back to the extent pool, the entire extent must be released. So if you have a one-track data set and it's deleted, it can't release that space in that extent. And so what happens is if you have little data sets that get created and deleted over time, what you may see is space start to increase for that logical volume. Another reason may be if you're doing a lot of flash copies, right? If you go and delete a data set and it's a flash copy source, right, that data is still needed to perform the background copy. Well, that space can't be released automatically. So we may try and release that space, right? But the DS8000 or the storage system may reject it, right? So other utilities that create and delete data, they may not be releasing space either. So the key here is as data is generated and deleted, you may see little storage creeps in your provisioned capacity for the storage system. So what we need is something else that we can run from time to time to go and clean up that space and do some garbage collection. So let's take a look at an example here. We have a logical volume and it has some of those chunks, right? And those chunks map to some, storage or capacity within these arrays, right? So when you initialize a volume, you're going to put a VTOC and a VVDS on it. And so the entire volume is free space except that first logical chunk, right? So chunks 2 through 22, when that volume is initialized, is free space. That's great, right? As we create data sets, spaces, obtained from that extent pool and provision to that volume. So we create data set 1, data set 2, we create data set 3, and then we do some writes to data set 2. Okay, so that's kind of what we're looking at here. So let's take a look at what happens if we go ahead and delete data set 3. Space for that data set, the VTOC is updated, the data set is deleted, the VTOC is updated, and we say, hey, release some space. And we from the host side say, release these tracks. Now those tracks may map directly onto one of those logical extents, or they may be a part of one of those logical extents, right? So in this example, that data set 3, it occupied a piece of extent 9, all of extent 10, and a piece of extent 11. Well, when we send that release space command down, the one chunk that gets released is chunk 10, right? So 9 and 11 can't get released because it is still part of, that some of that space is used for data set 2. So now here's the interesting thing. What if we delete data set 2, right? We stay on this slide. If we delete data set 2, we're going to send a release space command down. 5, 6, 7, and 8 are going to get released. 12 is going to get released. But what about 9, 11, and 13? It's all free space now. But those logical extents are not going to get released back to the extent pool. Okay, and that's why we need a space release command. So even though 9, 11, and 13, no allocated space to them, the way those release space commands came down caused it so that that space is still physically allocated in the extent pool capacity. So that is why we need a release space command. Next slide. So DFSMS DSS, it's a batch utility. We provided a space rail command and allow storage admins to do a volume level scan and release free extents from back to the extent pool. Okay. The expectation is this is for storage admins. And we have a new facility class to control access to that command. Okay. Next slide. What does it do? So the space release command, you can use it to release space from a single volume, a set of volumes, or an entire storage group. So those volumes must be online and they must have an indexed VTOC. Okay. So the first thing to think about is, okay, so you're telling me if I'm going to use thin provisioning, I have to, do this space release command from time to time. Well, how long is that going to take? Well, that's where, our friends in the DS8000 and the storage system have really helped us out, because the space release command now is very fast because it's an asynchronous command. Okay. We say release these tracks, they accept the command and give us good status. And at some point in the background, they will go and release those extents. So the space release command will lock up your volume, but it's for a very short period of time, just enough for us to issue the command down to the storage controller and get good status back. And then that volume is available for use again. Okay. Next slide. So we'll go back to this example and we'll take a look about, what space release will do for us. So again, we'll go ahead and we'll delete data set 3. We'll delete data set 2. And now all of those chunks got released back to the extent pool except for 9, 11, and 13, right? Now we can go and run space release, and that space release command will release those 3 chunks for us. Okay. Next slide. So now, hopefully we understand why we need a space release, what it does for us. So where are you going to run this command, right? It's extent pools that fills up, but from zOS, we have a view of logical volumes. Okay. So any pool of volumes that's used for transient data, right? Flash copy target pools, that's your bread and butter use case, right? It's probably quite common. You do a copy full with flash copy and then maybe dump that off to tape. You may do that for a set of volumes using DSS, or you may do that on a large scale using DB2 system backup with the HSM fast replication backup support, right? But the idea is the same. You flash copy some volumes and then you dump them off to tape and you clean up those volumes for use later. You can use the defrag with type run no run. We give you a volume map, and you can run those. You can run that on a volume to give you some idea on how much space you might reclaim for a particular volume. Next slide. So the other question you're going to want to ask yourself is when to run this command, right? And so you may have automation tooling that keys off of those IEA 499 easy alerts. And you could kick off jobs to go ahead and reclaim some space. But you might also consider running this if you still use defrag, right? You could run space release after that. If you use consolidate to reduce the number of extents, anytime you're manipulating the volume would be a good time to run the space release command. If you use HSM migration, right? Anytime after a primary space management window would be another time, right? So primary space management is going to go off and expire data sets, right? It's going to migrate data sets off the device. So after that window, there's a lot of free space that was physically allocated that could be reclaimed back to the extent pool. And really, I think what we've seen is, clients just on a somewhat regular basis, maybe weekly or bi-weekly, run a space release command on a set of storage groups to kind of not reclaim every little extent that is free, but just free up enough extent to keep going, right? Next slide. So here, what could we see you doing, right? So we could see you using list data, right, to give you a little bit of a report, and then running the space release command, and then doing a list data after to see how much capacity was reclaimed. So using list data with the space release command can give you a before and after report. The reason we'd say use list data is, unlike the defrag and consolidate commands, DSS doesn't do any reporting about reclaimed space. So that's why we would say use the list data in conjunction with space release. Go ahead. Next slide. Okay. So our first enhancement we want to talk about is this min-sils keyword that we've added to the space release command. And so right now, what that command does internally is it gets information about all of the free extents or tracks or cylinders on the volume, and it builds a command and it says release all that space. Okay, it's pretty dumb. Now, a lot of the extents that it asks to reclaim have no possibility of reclaiming a physical extent, right? So for example, the space release command in this top here, we have a 10001, right? And those first three free tracks span extent 1 and extent 2. So we would send that down, and there's no way that extent is going to free any space. So with this min-sils keyword of 42, right, and this 42 number maps to the DS8000 storage subsystem extent size. If you're using another storage vendor, there's maybe another number you would plug in here, right? But if you say min-sils of 42 on a DS8000, that means that every extent that we send down to release will release at least one physical chunk back to the extent pool. So if you're DS8000 using small extents, we would say use min-sils 42. Okay. Next slide. So what about managing these things, right? So we dump them.
Robert, there was a question around space release
Yes.
there, and maybe worthwhile to cover it before we get onto the dump support. So Martin was asking if there's a benefit in doing space release if we're not over provisioning. And I think that there's a few things here. Number one is if you're on the 8900 with the latest levels of code, doing that space release will free up the back-end flash capacity, which means that the flash drives are have more over-provisioned space and will perform better. RAID rebuilds will happen faster, etc. The other thing is if you're in a tiered environment, either with two different types of flash, or if you're on an 8880, which is a hybrid machine with HDD, then you're you won't have unallocated empty space on the lower tiers, and new allocations in that empty space will allocate new data, which would typically be on the upper tiers. So, you know, even if you're not over provisioning, there can be benefits. And the other thing is, if you're not over provisioning on the primary, you might be over provisioning on your global mirror target, and that space release will flow down and you'll get the capacity benefits on the target. So, you know, certainly, yes, there are benefits to doing it if you're not over provisioning.
And as far as the impact of the space release command to the primary device, we do lock up the volume, but the period in which we lock the volume is a very short period. And that is because the command is now asynchronous at the storage controller level. So we lock the volume long enough to basically get information about the free space, build a command, and send it. Okay. So when we talk about managing these volumes, we'll go pretty quickly through these last slides here. A DSS full volume dump, or even HSM backvol, right? A dump of a thin provision volume doesn't use any more or less space than a fully provisioned volume. Okay, so by default, we don't dump unused tracks on a volume. We do dump allocated but unused space within a data set, but those take up 32 bytes each. So whether that was, so you have a data set, it has some free space, whether it is provisioned or not, each of those empty tracks would take up about 32 bytes. So there isn't any increase in your offline capacity for using thin provisioning. Go to the next slide. On the restore side, there is one thing to consider. And that again is the allocated but unused space within data sets. Now on the volume we dumped, that space may not have been provisioned. When that volume is restored, we're going to write those empty tracks out and they will get provisioned. So that would be another case where you could go ahead and run the space release command after the restore. Okay, so we're out of time. There's a couple more slides we can try and get through. Is that okay? Or
yes, I think we've got a little bit of leeway there to cover the last couple of charts.
All right, next slide. So so that primary use case of a copy full with flash copy followed by a dump full to tape, right? We use withdraw to withdraw that flash copy relationship and really free that space back to the extent pool, okay? And so if you go to the next slide, within DSS, we really prefer to use ICK-DSF init instead of a withdraw, right? That is going to remove the flash copy relationship. It's going to ensure there's a valid VTOC for the next backup cycle, and it's going to release space from the extent pool for thin provision volumes. And so our design, there were some issues with it, right? We wouldn't use ICK-DSF all the time. And so those conditions were that the VTOC was already copied. Now this was silly, in my opinion, okay? Because we made this decision that if the VTOC wasn't copied, we're not going to initialize the volume. because the VTalk was good, even though the VTalk could be pointing to data sets that are not on that volume at all. So I think that was a bad decision on our part. And then less frequently, but something we've seen, is we would call ICKDSF, but it would fail because something else allocated the volume. And this was very interesting because the volume is a dump condition volume. And really, you can't open data sets on those. These are DSS only volumes. They're not usable by any application outside of DSS, or so we thought. So what happened was we weren't releasing space back to the extent pool for these flash copy targets. So we took an APAR, next slide, and we always now issue an ICKDSF init, okay? And that ensures we release space back to the extent pool for those flash copy target volumes. Okay, next slide. What we found, the thing that would prevent us from using ICKDSF init was SMF space switching in LSpace. And so what happened was every time the SMF recording switched data sets, it goes and does a volume report about all the online volumes to the system, right? And so we saw this a couple customers. The ICKDSS would fail and space would start piling up. And so we've added a parmlib option to devsupxx to suppress SMF19 gathering for dump conditioned volumes. So now that recording can go and it can tell that it's a dump conditioned volume. It can not do the LSpace for that. Next slide. Space thin provisioning and space management. So if you use HSM space management and you decide to over provision. Now, if you don't over provision, you don't need to change your migration thresholds at all. But if you decide to over provision, you may adjust your migration thresholds so that space management runs when you want it to. If you don't adjust, right, and you standardize on all 1 terabyte volumes, guess what? Primary space management is going to run less frequently. Next slide. And finally, we preserve mirror within provisioning. And this is another little aspect where, you know, we weren't able to free space on a Metro Mirror secondary because of flash copies and orphan relations going on. So another, you know, the standard use case again, right? You flash from H1 to H1 prime, dump it to taper cloud. And you might run a space release after that, right? Before the next cycle. And next slide, what was happening is orphan relations were getting hung out on the Metro Mirror secondary. So if you ran a space release, that space wasn't getting reclaimed back to the extent pool. So what we did here is we took a APAR in software. Next slide. So this is one of our newest ones, 57549. It's an HSM APAR, right? And it ensures the flash copy relationships are cleaned up on the Metro Mirror secondary, okay? So that when you go ahead and run space release, that space can get reclaimed, okay? It affects the FR backup copy pool, dump only. So this starts into the DB2 backup system. And it supports all of your, you know, replication configs, Metro Mirror, MGM, and multi-target. Okay, we did not update DSS for this. So last slide, I believe. This is disabled by default on 2.3. It's enabled by default on 2.4. So if you're on 2.3 and you want to enable this, you go ahead and set that patch. And with that, that is it.
Okay, thanks very much. I think there's one question in the chat from Andy Gray about the fragmentation index and whether that gives you any insight.
So the question was, could you tell by looking at the fragmentation index that you'd be impacting performance? Is that impacting performance in terms of doing the space release command?
So my thought is the fragmentation index isn't necessarily going to tell, well, the performance of the space release command will not change, whether it's highly fragmented or not fragmented, because the I/O we do to get the free space information is the same, and it's negligible. If there's more free space extents, right? We're really using CVAP to get a bitmap, so it doesn't matter.
Yeah, I mean, I think in terms of if you had a volume that, and let's take the extreme example, if you have a 1 terabyte volume and you allocate every other 21 cylinder extent, the space release command issued can take longer because it has to, issue many different individual 21 cylinder releases. Whereas if you have one, 950 gigabyte free space, it's a single command. And that's one of the reasons the min cylinders command option was provided, to say, actually, I'll ignore space under a certain level. Now, as Robert said, the performance of the command now is a lot faster than it was originally, but that would be one use case for the min cylinders option, is if you had volumes that typically were very fragmented, then you could potentially use that option and set it to 42 or even a larger number, and it just won't go ahead and try and free up a lot of space that doesn't exist. But I have to say, the real world experience to date has been that no one has noticed and complained of a problem so far. So I think it's a theoretical possibility, and the min cylinders could let you work around that by setting that, but we haven't actually seen anyone notice that. And I've certainly followed up specifically with some of the earlier adopters over the last couple of years and explicitly asked that.
Okay, we are actually getting quite short of time. We have to hand this room over to the next session. So this presentation has been slightly over provisioned, I think. The event manager is called Gino, and I don't want to piss off anybody called Gino. Just seems sensible. Are there any very quick questions? I'm hoping not. Okay, thanks very much to Robert and Nick. Excellent session. It's always good to have sort of the asides about what people are doing and why they're doing it. It's nice to see that thin provisioning has moved from being something that it would be nice for somebody else to try to something that really must be using. So thanks again. Please submit your session feedback. Put a link in the chat. And finally, again, thanks very much to Nick and Robert. Thanks.
Thank you.
All right. Thanks, everyone.